So in this video I want to talk about the concept of half reactions. But before I do that, I want to say a little bit more about this last reaction that we introduced in the last video. We talked about identifying whether an oxidation or a reduction has occurred. And we mentioned that whenever something is oxidized, we call that the reducing agent. And whenever something is reduced, we call that the oxidizing agent. All right, and I just want to point out that that can be a little bit counterintuitive. All right, but there's an example that I can give, which I'm going to talk a lot more about later, that I think makes this concept make a little bit more sense. All right, so I'm going to use this example that everyone can relate to. We're going to take a wet body and we're going to use a dry towel. And what are we going to have in the end? We'll have a dry body and a wet towel. All right. So if you were to take a look at this and say, what is the drying agent? All right. I think that most people could recognize that between the wet body and the dry towel, it's the dry towel that you would consider the drying agent. All right. But notice what happens to the drying agent in the course of it doing its drying action. All right. It becomes wet. All right. So the drying agent is the object that is getting wetted. All right. In this case, the wetting agent would be the body, and what's happening to the body, it is becoming dry. All right. So the wetting agent in this particular process is the object that's getting dried. All right. So whatever you call something as an agent, the opposite is actually happening to it. All right. So that's why whenever an object is being oxidized, well, if it is being oxidized, that means something else has to be being reduced. So if it's being oxidized, that's why it's a reducing agent, because it has to be causing a reduction somewhere else. All right, and the vice versa is true about the oxidizing agent. So although anything that is getting oxidized in a reaction could be considered a reducing agent, generally these terms are reserved for things that are strongly oxidizing or strongly reducing. All right. So some common oxidizing agents. In fact, one of the reasons we call it oxidizing is that in our atmosphere, oxygen is so present, and so it's one of the most common oxidizing agents that there is around. All right. So, for example, why does an iron bar rust? It happens because it's in an oxygen atmosphere. But these are some common chemicals that are commonly considered oxidizing agents. And these make the list because they're strongly oxidizing. These would oxidize things that wouldn't normally be oxidized under mildly oxidating conditions, but they would with these particular chemicals. All right. Reducing agents aren't nearly as well known, and one of the reasons that they're not as well known is if you think about what types of processes would we likely see here on Earth. All right. Well, we live in an atmosphere that's got a lot of oxygen in it. All right. So we're much more familiar with oxidations occurring, but there are chemical reagents that would be considered reducing agents. One of those is hydrogen gas. All right. Again, we don't have a whole lot of hydrogen gas in our atmosphere, so we don't really worry about objects being reduced in the same way that we worry about them being oxidized. All right. So moving on, half reactions. So even though whenever you have an oxidation reduction reaction occur, we have both of these processes happening in the same reaction, we can actually split this up into two separate reactions. All right. And what we call these are half reactions, and these are going to show the individual oxidation and reduction steps happening individually. All right. So I'm going to go and start with an analogy here, going back to the wet body and dry towel analogy. In this particular process, there's a drying reaction going on, and there's a wetting reaction going on. And hopefully you realize that this overall reaction involves the transfer of something. It involves the transfer of water from one thing to the other. So could we split this up into two separate reactions? All right, well, what's the drying reaction that's happening here? All right, well, the drying reaction involves the wet body becoming the dry body. All right, and the wetting reaction involves the dry towel becoming the wet towel. All right, so the thing about it is that there's a transfer of a material that we haven't talked about here. All right, I think most people realize that it's water that's being transferred. So if we were to take a look at this and say, what do we need to balance this drying reaction? All right, well, the thing that's missing here is that when something gets dried, the water that was in that is somewhere. All right, so we're just going to list that as another product. So the drying reaction would be wet body makes a dry body plus water. All right, the wetting reaction is going to be the dry towel plus water. All right, and hopefully you realize, where did the water come from? It came from the wet body. All right, plus the water becomes the wet towel. All right, so notice that these are two separate reactions, and whenever we add reactions, if you see something on the reactant side of one, it cancels with the something on the product side of the other, so we could cancel water out. But even though water isn't shown in this reaction right here, we know that there's a transfer of water here, and that's what the half reactions do. They show the separate steps, and they show the water is actually either a product or a reactant in the process. All right, so we're going to apply the same concept to oxidations and reductions. All right, so let's take a look at this reaction right here. So we've got this is iron chloride. This would be iron 3 chloride specifically, reacting with zinc to give zinc chloride and iron as a metal. All right, so one of the first things that you can do in this process is anytime that you see something that's aqueous, remember that when an ionic compound is aqueous, it's going to exist as its dissolved ions. All right, so when you have this, what you would actually have is iron plus 3 ion and Cl minus ions. All right, so let me go ahead and draw that. All right, so notice that I drew 2 of these aqueous iron 3 ions because that's what you would have because of that coefficient. You would have a total of 6 chloride ions. All right, just bringing down the 3 zincs is what we did right here. Again, this is aqueous, so we can split it up into its separate ions. All right, and then just bring down the iron. Okay, so taking a look at this overall reaction, can we spot the separate oxidation and reduction processes that are happening? All right, let's trace this iron right here. It's going from iron plus 3 to iron neutral or iron 0. All right, well, if you take a look at the oxidation numbers, which in this case would be the same as the charge, you're going from a plus 3 to a 0. All right, so the charge is literally being reduced. So that would be the reduction. All right, so if there's a reduction, there has to be an oxidation going on somewhere else. And where that's happening is this zinc is going from a charge of 0 to a charge of plus 2. That's an increase in the charge, so that's an oxidation. All right, so what we're going to do is we're going to split up these two, the oxidation and the reduction steps, into 2 separate steps. All right, so the oxidation, zinc going to zinc plus 2, we're going to show it like this. All right, but if we didn't put this in right here, all right, we know that there's either a gain or loss of electrons here, because we can't just go from a neutral thing to something with a plus 2 charge. So the thing that gets transferred is 6 electrons. So notice that there should be a charge balance between the two sides. You have an overall charge of 0 on this side of the reaction. There should also be an overall charge of 0 on this reaction. So 3 positive 2 charges plus 6 negative 1s, that all adds up to 0. All right. So similarly, we could do the same thing with the reduction half reaction. So going from iron plus 3 to iron 0. All right. Notice that in order to go from here to here, we need to add the 6 electrons that are added to the iron atoms in order to give the neutral atoms. All right. So notice that in this overall reaction, there's actually something else that hasn't been mentioned in either the oxidation or reduction, and that's these chloride ions. All right. And notice that the oxidation state doesn't change from start to finish. All right. And the name given for any ions that don't have any change in their oxidation state going from start to finish is spectator ion. All right. It's not the reason it's called a spectator is it's not actually participating in the reaction. All right. So let's give this a little practice. And in this practice, I want to encourage you guys to pause the video and see if you can figure things out for yourself. All right. So the first reaction that we're going to do is lithium plus zinc nitrate going to zinc plus lithium nitrate. Okay. So again, what's the first step? We need to separate our aqueous ionic compounds into its separate ions. That would give us this. All right. We then need to identify our oxidation and reduction. All right. So lithium going to lithium plus, that would be our oxidation. Zinc going to zinc plus 2 going to zinc metal would be the reduction. All right, and notice that in both cases you have to have electrons to keep the charges balanced. All right, and if you not only that, if you were to add up these two reactions, you notice that the electrons would cancel out. All right, so in this case, in this overall reaction, what would the oxidizing agent and then reducing agent be? Well, since lithium is undergoing an oxidation, all right, it would be the reducing agent. It's the thing that supplies the electrons that allows zinc to be reduced. So lithium is the reducing agent. Zinc or zinc nitrate is the oxidizing agent. Okay, so both of these answers could be considered to be correct. Zinc nitrate would be considered correct because you'd say that's the chemical that we added to the reagent, to the reaction that caused the oxidation to occur. But technically, when it's dissolved, it's actually the zinc ion that is doing the oxidizing. So either of these would be considered correct. All right. And are there any spectator ions? Well, let's take a look at this reaction. Did anything happen, and was there anything in this reaction that didn't end up in either the oxidation or reduction? That would be the nitrate ions. All right, so those are the spectator ions. All right, another example here. All right, let's see if we can spot, say, so let's look at the potassium here. Here it is a 0 charge and it's going to a +1 charge. That's what it that's the charge that it would have in potassium chloride. So a 0 to a plus, that is an oxidation. So here's what that half reaction would look like. All right, notice the 2 electrons. That's what's needed that's actually what is given up by these atoms when it gets oxidized. The reduction would look like this. Potassium would be the reducing agent. Chlorine would be the oxidizing agent. And in this particular reaction, everything that you see in the original reaction is shown in the half reactions. So there are no spectator ions in this particular case.